Hi everyone, today we're going to look at solving systems of equations graphically, but this time instead of it just being in y equals mx b slope-intercept form, we're going to look at equations that might be written in standard form like this system below. So if I want to solve this graphically, I have to first change it into slope-intercept form. So for 2x plus 3y equals 12, if I want to change that into slope-intercept form, I'm going to solve for the y value. So I'm going to move over the 2x. I'll have 3y equals negative 2x plus 12. Then I'm going to divide everything by 3, which would leave me with y is equal to negative 2/3 x plus 4. I'm also going to change the other equation in blue into slope-intercept form. So I'm going to subtract over the 2x. I'm going to be left with negative y equals negative 2x plus 4. And then I'm going to divide by negative 1 on both sides. So y is going to be equal to 2x minus 4. And now I'm going to graph both of them. So I'm going to graph this one first in blue. So I'm going to start at negative 4, and then it's going to go up 2 over 1, up 2 over 1, and so on. I'm going to draw my line. And I'm going to graph the red line as well. So that one's starting at positive 4, and it's going down 2 over 3. Down 2 over 3. So that would be the intersection point. So right here is going to be our solution. So our solution is going to be that point 3, 2. That's going to be the solution for this system. For this example, you'll see y equals 4 minus x is already in slope-intercept form, so we don't really have to do anything with that. We can just go ahead and graph that. So starting at 4, and then the slope is going to be negative 1, so it's going down 1 over 1 to the right, or up 1 over 1 to the left. So we create this line right here. And then if we had to graph the other equation, we would have to change it so that it is in slope-intercept form. We could also find the intercepts, but I think for this question, I think we're just going to stick with changing everything into slope-intercept form. So here, and I'll have y equals negative x plus 4, which you'll see that this equation and the red equation are basically the same thing. They're just in different order, right? They just switched the order. So by commutative property, they would be exactly the same thing. So if I went to go graph this blue equation, it would start at 4, and it would go down 1 over 1, down 1 over 1, down 1 over 1. So it's literally sharing all of the same points, and it will even have it'll make the exact same line. So therefore, when we're thinking about a solution for this, anything on this line is a solution. There's technically, for this question, there's technically what we call an infinite amount of solutions. So what that means is that I could find points anywhere on this line, that would be a solution. So for instance, the point 6, -2 is a solution. 5, -1 is a solution. 4, 0 is a solution. 3, 1 is a solution. 2, 2 is a solution. 1, 3, and so on. All of these are solutions, and anything in between those are also solutions, right? All of these points that are not integer points are also solutions. So there's an infinite amount of solutions. It's never ending, this line, so there's going to be a never ending amount of solutions. And that's going to be it for today. Thanks for watching.